Get started in about a minute.
Hello.
How's it going, Ben?
Good. How are you?
Not bad. Tomorrow's Friday. All right, any questions on the homework?
None.
I'm going to call out the evens. The odds were in the back of the book. All right, number 2, I had an A and a B. A, the slope is 0. It's a horizontal line. B, the slope, it's a vertical line. So undefined. Number 4, slope is 7/3. Number 6, 1/5. Number 8, it's vertical line, not defined. Number 10, -9/2. Number 12, the slope is -3 and the length is 2√10. 2√10. Number 14, the slope is -2/11 and the distance is 5√5. Number 16. Oh, this is a sketch, so I have to look at that. That's 16 and 18. So pick it up on 20. The slope of PQ equals the slope of QR, and both of those equal 4/3. Number 22, 22.5 feet. 22.5 feet. And 24, the answer is 3. 3. And that's it. All right, 24 was 24 and 25. Yeah, 24 and 25. You had to give those one a little bit of thought. Probably needed some graph paper for that. All right, let's see. Oh, yes, algebra, our last algebra review of the year. There is no algebra review 14. All right, we're going to jump right in. I'm going to go over the, 4 or 5 exponent rules. Let's see how much of this you remember from Algebra 1 and pre-algebra. If you need to refer to this, the book doesn't do a good job of on the homework. It just basically says what's the answer, so it doesn't do a really good job. So if you need to play the video while you're doing your homework and review that, I'll have it posted within, I don't know, within the nearest half hour after the class is over. All right, so probably by 2:30 I'll have it posted. All right, here we go. Exponent rule number 1. Well, first off, let's talk about what it means to be an exponent. Well, when you are an exponent, it's a way of showing repeated multiplication. I've got 2 things there. I've got a number in blue, or a variable in blue, and a variable in red. The variable in blue is on the bottom. McKinley, you remember what the bottom number is called?
The base.
You got that right, McKinley.
That was
unlike Ben.
That was me.
I know it was. All right, the real McKinley. What's the M called?
The unlucky exponent.
Yeah, or power. Either called the exponent or power. And remember, it's a way of showing repeated multiplication. So somewhere in there is multiplication. And just remember, the base is the number that's being repeatedly multiplied. The 3 is how many times the 2 is written. So the 2 is written 3 times. And since it's repeated multiplication, then there's multiplication symbols in between. 2 to the 3rd power, 2 times 2 is 4, times 2 is 8. So the answer to 2 to the 3rd power is 8. What it is not ever, and many of you have made this mistake this year, it's not 2 times 3, right? 2 times 3 is 6, and we just saw that the real answer, 2 written 3 times, is 8. Now, there are a few exceptions, and no, we don't pay much attention. I mean, this literally is the same as 2 times 2, right? But that's one of the there are a few exceptions, but majority of the time, 99.9% of the time, it's the base written the number of times as is related to the power. Okay, some quick examples. Remember, the base is 13. I need to write 13 3 times. The base is 13. You need to write it 3 times, multiply. Whatever that answer is the answer. Remember, on your calculator, you have the caret key to do that math for you. Most calculators have a square button. Some have a cube button. But as soon as you get higher than 3, then you got to find that caret key to do this. 13 to the first power, anything to the first power is just the number itself, the base. Anything to the first power is just the base, including 0. 0 to the first power is 0. As soon as we put parentheses, we will include the parentheses. So the base here is not 13, but technically it's parentheses 13 written 3 times. And you're like, well, that wouldn't make any difference. True, but it would make a difference if there are negatives involved. Okay, so when there are negatives involved, we come to, and by the way, this is called the expanded form. The other form there to the left is called exponential form. Expanded form just means take the base, write it how many times as the power is written. And then if you actually do the math, that's called the simplified form. So to get to the answer, the question will read, simplify all these expressions. Well, the first thing you need to do is expand it, right? 3 2 times. And then do that math, and that math is simplified. In other words, using GEMDAS, do the simplification. Okay. And the big issue here is not when things are positive. The big issue here is when there's negative. So here's your first that we'll spend a little bit of time on, just reminding you of what the answers. Now, I've broken this slide down into 2 parts. We got the left part, big vertical slash, and then the right part. And they're labeled negative on the outside, negative on the inside. And what I'm talking about is on the right side there, we got parentheses, and the minus sign is on the inside of the parentheses. Well, technically on the left, it's not negative on the outside, but there's just no parentheses. How about that? No parentheses. We get vastly different answers for both of these. Now watch what happens. Turns out on the left side, the base here is not -3 by definition. So by definition, the base here is not -3. The base is 3. So the base is 3. We write 3 3 times. And then we stick that negative or that subtraction symbol in front of it. Either way, negative or subtraction. Notice that when the negative is on the outside or there's no parentheses and there's a negative involved, it doesn't matter. You will always get a negative answer because you're attaching that minus sign at the very end. So you will always, always, always get a negative answer, no matter what's there, variable or number. The answer will always be negative. That will not occur, however, when you have a negative inside of parentheses. We had 2 special cases. All right, the first one, notice the base here is parentheses -3. The power is an odd exponent. Well, I got to write parentheses -3 3 times. A negative times a negative is a positive, times another negative is a negative. And that will always occur when the power is odd. Right? When the power is odd, the answer is always negative. Right? When the negative is on the outside, the answer is always negative. So here's 2 cases where the answer is always negative. The only time you get to a positive answer is when the power on the outside of the parentheses is an even number. Why? Well, because you have an even number of negative numbers being multiplied together. When you have an even number, they pair up and they become positive. So bottom line, this is a pretty busy slide, but this is something that most time you're doing this all in your head. You got to be careful. If there's no parentheses and there's a negative, it's always negative. If there are parentheses, then it just depends whether the power is odd or even. If the power is odd, the answer is negative. If the power is even, the answer is positive. Okay, so that's our first little tricky part dealing with X. There's more, but that's our first little tricky part, is keeping those 3 rules straight in our head. Any questions?
No.
Okay, so McKinley, the first one, the answer is it positive or negative?
It's -8.
It is negative, right? And the final answer is -8. Why? Because there's a negative on the outside, no parentheses. 2 times 2 times 2 is 8. Attach a minus sign or a negative and you're done. Ben, the middle one is?
The middle one is negative because the negative symbol is inside the parentheses.
And?
It's 3. It's an odd number.
And it's an odd number. That's actually why it's negative. It's not because the negative is on the inside. It's because the power is odd and there's a negative on the inside. All right, and notice when you multiply with odd, then you're going to get a bunch of ones that pair up, and then you have one left negative all by itself, and that's what makes your final answer negative. And McKinley, the last one is?
Positive 36.
Right, and I think I'm leaving out Anna here, so yes, that is correct, because evens would pair up. Anna, any questions?
No.
Cool. All right, well, that was rule number 1. Rule number 2 is anything to the 0 power is 1 with the exception of 0. We don't say 0 to the 0 power is 1, but anything to the 0 power is 1. I mean, literally anything. 5 to the 0 is 1. X to the 0 is, as long as X is not 0. Even this big, ugly, I love to put this one on test. Why? Because it's got a whole bunch of things that you could do on the inside, but on the outside, there's a power of 0. It's still 1, right? Doesn't matter. Anything to the 0 power with exception of 0 is 1. Rule number 3, we're going to just march through these very quickly. Rule number 3, this is called the multiplication rule. Paradoxically, the multiplication rule, no, I'm not going to explain this to you because I literally did prove this one to you in Algebra 1 and pre-algebra. The multiplication rule says to add the exponents with one caveat, and the caveat there is that the bases must be the same. So this only works because this base is A and this base is A. But when the bases are the same and you are multiplying, it's just not drawing, and you are multiplying, then all you do is rewrite the base. I did it again. Why is it being mean to me today? Rewrite the base and add the exponents. But you got to make sure the bases are the same. You got to make sure the bases are the same. So let's see this with some real numbers right here. Check it out. The bases are the same. I've got a 3 and a 3. When the bases are the same, rewrite the base and add the exponents. 4 plus 8 is 12. So 3 to the 12th power. Now the question is usually, wait, is that the answer, or do you really want me to multiply 3 12 times? There is no rule for this, right? There's only some guidance. And the guidance is, if you can write 3 to the 12th and do that math easily, right? Or you can write the answer easily, then do it. If it's, if that ends up being something in scientific notation, then I would just leave it as 3 to the 12th power. But if it's 2 to the 3rd power, yeah, you're going to write 8. All right, remember, you can only do this if the bases are the same. If the bases are the same. That includes variables. Excuse me. As long as the bases are the same, you rewrite the base and you add the exponents. It's called the paradox rule because, well, to multiply, you add, right? No multiplication here, add. Well, what happens here? Notice that first one right there, I do not have like bases. One is a 2 and one is a 3. So how do you actually do this? Well, one thing it is not, and I shouldn't even show you this, it's not that you don't multiply the bases and then add the exponents. That is not true. What you do, if this is really what you're asked to do, well, then you have to do it the long way. In other words, I got to do 2 to the 5th. 2 times 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 2, 5 times. 2 times 2 is 4, 8, 16, 32, and 3 squared is 9. So this is really 41 is the answer. Notice 6 to the 7th is not 41. It's a huge number. So don't make this, oh, wait, I'm sorry. Nobody caught me on it, so no points for anyone. This was supposed to be multiplication. That was supposed to be multiplication. No, not
Dang
that.
it, we weren't paying attention.
Clearly. All right, so that is really 32 times 9, which would be an 8, 2288. Is that right? 288?
Yes.
Yeah, okay. Now it's right. All right, and even 288 is not 6 to the 7th power, right? When the variables are different, you can't do anything with it. You don't multiply the two variables together and add the exponents. That's not the answer. You simply squeeze them together, and that's, well, there's nothing you can do, basically. All right, so that is the rule for multiplication, which is basically to add. Rule number 4, the division rule. Paradoxically, the division rule isn't divide, the division rule is subtract. If the bases are the same, you simply rewrite the base and subtract the powers. Now, the order does matter. It's going to be top power minus bottom power, but only for like bases. If the bases are not the same, you can't do this rule. So for instance, check it out. I got an x and an x. Those are like bases. So I rewrite the base. 7 minus 3 is 4, so the final answer is x to the 4th. Other people, and I know I taught you this, so you probably remember this, I say that there's 7 x's on the top, there's 3 on the bottom. If you were to write this in long form, 7x is 1, 2, 3, 4, 5, 6, 7. Remember, exponents are just repeated multiplication. There's 3 x's on the bottom, 1, 2, 3. So when I cancel, x divided by x is 1, x divided by x is 1, x divided by x is 1, I'm left with 4 total x's, in other words, x to the 4th. Some people in their, nobody does what I just wrote out, but many people in their head think about this. 7 on the top, 3 on the bottom, you're left with 4 on the top. All right, this one sometimes trips people's up, and that's only because they forget that the power here is 2 to the 1st power. We're just lazy. We never write anything to the 1st power. You still follow the same rules. As long as the bases are the same, you rewrite the base and subtract the powers. 7 minus 1 is 6. Well, here's a case, right? No, there's no rule here, but you can do 2 to the 6th. Let's see, if 2 to the 5th was 32, then 2 to the 6th would be 64. All right, any questions on that rule?
Nope.
Okay, this can get slightly complicated if you have multiple bases. Just remember, you can only do this with like bases. So I can't do the 2 and the x together, but I can do the 2's with the 2's and the x's with the x's separately from each other. In other words, I could do, just looking at the 2's, those are same bases. I could do 2 to the 5 minus, oh, there's another mistake. Good Lord. 3. All right.
Whoa, math mistake.
Oh, I caught it. That's 2 of them I caught. So 5 minus 2 and 7 minus 3. So let's see. That's 2 to the 3rd, x to the 4th, and 2 to the 3rd is 8. So 8x to the 4th. And that's how you handle those. All right. There's something in human nature, and I've had other people comment on this as well too. Not only in math, but when you create something so many times, you don't see your errors until you actually present it. Like I'll type a document and I won't see any spelling errors or grammar errors until I actually print it out. I don't know, there's something about printing it out or showing it that you actually notice when there are mistakes. All right, we're up to rule number 5. This is called power to a power rule. And power to a power rule is the thing that we were looking at before. This one is the one you don't add, you don't subtract. This is the one that you multiply. Now, I don't need like basis for this. That power on the outside goes to all the powers on the inside. It's kind of like the distributive property if there's multiple things on the inside. So all I do is multiply the exponents together and rewrite the base. So I rewrite 4, 5 times 6 is 30, and we're done. We certainly don't want to do that one. This also works with variables. 8 to the 6 to the 2nd power would be 6 times 2, which would be 12. Oh, questions? Power to a power rule?
No.
And I believe this is the last one. This is the negative exponent rule. Okay, let's talk about negative exponents. I usually talk about this by an example. Let's just say that we had division and we were doing x to the 4th over x to the 7th, right? We write this in expanded forms. We got 4 x's on the top. We have 7 x's on the bottom one. I'm already yelling the answer. 2, 4, 6, 7. And when we canceled, when we did some canceling, remember anything over itself is 1. Well, that's a 1, that's a 1, that's a 1, that's a 1, and we're left with 3 x's on the bottom. So in other words, the answer, we're only left with 1 on the top. Where am I getting the 1 from? Well, x1, these blue lines mean 1. 1 times 1 times 1 times 1 is 1. And on the bottom, we have x to the third. Okay. Well, let's think about this. If we were to follow the division rule, the division rule says if the bases are the same, you subtract top minus bottom. Well, that would give me x to the -3. And there's an example of how you can see that negative exponents actually turn into this. So what is the rule? The rule is if you have a negative exponent, it swaps position. If there's a negative exponent, the base stays the same. You never mess with the base, but you move the entire thing, the base and the exponent, to a different position. If it's on the top, you move it to the bottom. If the negative exponent is on the bottom, you move it to the top. You get rid of the negative symbol. Notice my final answer here, 1/8 of the m does not have a negative number in it. So you also get rid of the negative exponent. All right. So 3 to the -2, well, it looks like it's on the top, so I'm going to move it to the bottom and get rid of the negative, and then simplify. 3 squared is 9, so we get 1/9. With parentheses, be careful. -3 is an odd number. I got a negative on the inside, so my answer is going to be negative. But I got to follow the rules. So let's see. I got to move it to the bottom, make it not the coefficient, or I shouldn't say the coefficient, not the 5. Don't make that positive, but make the 3 positive. We know the bottom is going to turn into -5 times -5 times negative. It's going to be negative. So we're going to get -125. We'd probably put that negative in the middle. These can get slightly complicated like this. You just got to think your way through them. All right, a couple more. This one's tricky. We got negative exponents on the top and the bottom. We don't have like bases, so I can't even do subtraction here. What can I do is, well, I can follow the rule. The rule says if you have negative exponents, you move its position. If it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top, and you make things positive. We're talking about the exponent, not the base. So the base always stays whatever it was. But notice I've moved position. The 4 to the -2 is now 4 squared on the numerator. And the 3 to the -3 is now 3 to the third in the denominator. All I did was flip positions and made the exponents positive. We can do 4 squared, that's 16, and 3 to the third power is 27. As they say in Italy, that's it, and that is it. I got nothing for you. That was a bunch of rules. We had the negative exponent rule, rule 6. We had the power of power rule, that's rule 5. You multiply the powers. We had the division rule, that means subtract, as long as the bases must be the same. We had the multiplication rule. The multiplication rule, I'm clicking too many times, is to add the exponents. We had the anything to the 0 power is 1 rule, and then the first rule we had, which was basically, well, how do you expand and simplify exponents? Rewrite the base, write it so many times as the power is, and if there's negatives involved, we got this big ugly fraction, or big ugly slide right here. Just remember, negative on the outside, no parentheses, the answer is always negative. Negative on the inside of parentheses, it just depends whether the power is odd or even to include negative or positive exponents. If it's odd, the answer is negative. If the power is even, then the answer is even. And that's it. Literally, that's it. That was a quick down and dirty run through of rules for exponents. Your homework for tonight, because that's it. I don't know why I wrote that, but here's your homework. It's basically every problem. So it's Algebra Review number 13, 1 through 24. All these are done very quickly. This is not even 15 minutes worth of homework. This is about, depending upon how quickly you can write, this is 10 to 12 minutes worth of homework. If you run into any problems on any one, send me a chat or something like that. I'd be happy to give you a hand on that. And we will get back to the chapter 13 stuff tomorrow. Questions?
No.
Anna, questions?
No.
McKinley said no, so that's it. Jack is too scared to show up every day, so I'm sure he has tons of questions, but we will all hear them on Monday when we're all back live. All right, I really look forward to that. I've been missing you guys. It was nice to see you on Tuesday, or was it Wednesday? Tuesday. I saw you on Tuesday. And I look forward to seeing you guys on Monday. Have a good rest of your day, and I'll see you guys in class tomorrow.
Goodbye.
Bye.
Goodbye.
Yep.